Good morning, Grade 8. How are you guys doing today? Welcome to this physical science lesson. This is Marshall AC Candiado. Today we'll be looking at, we'll be moving to this topic on electricity. And the first thing we're going to do is look at electric charges and how substances, objects, materials become charged. That's what we're going to be doing today. So by the end of this lesson, you must be able to state the charges that are found in atoms, bearing in mind that atoms are found in all the materials that you see around you. All matter is composed of atoms. Okay? Explain how materials may become charged, materials or objects. We will explain what becoming charged is, differentiate between a conductor and an insulator, as well as drawing the diagram of an electroscope. You will find that at the end of this lesson, there's going to be, there's a diagram on an electroscope, but we're going to have that also as a stand-alone lesson. Okay, so let's just have a look at these objectives. Pause the video for a bit, look through the objectives, and try to see if you know any of these things prior to me telling them to you. Okay? Okay, so what I'm going to do is I'm only going to explain some of the parts, some of this information, but I'm going to play you a video which I think is very descriptive in terms of charges and how they move from one person to an object, from one person to another, etc., etc. Right? So what we know is that we talked about atoms. We talked about elements. And I hope you remember what was found in the atom. Right? When we went deep into the atom, we went into the nucleus of the atom, we found that there were subatomic particles that were in the nucleus of the atom. Okay? And then we found that surrounding the nucleus of the atom, there were other subatomic particles that were there. The particles that were surrounding the nucleus, can you recall what those particles were and what they still are, because they are still there? It's not like they've gone to Hollywood or to LA or wherever, they are still there, right? So pause the video and try and write down the subatomic particles that are found in an atom. Okay, so you'll find that if you recall, I'm observing now that the answers were just here. The answers were here, but still, the atom is surrounded by, the nucleus of the atom is surrounded by negatively charged electrons. And in the nucleus of the atom, you found that there were positively charged protons, right? There were positively charged protons, but then also in the nucleus there were neutrons, okay? There were neutrons. So we had all these subatomic particles. And then what I'm going to do now, because I will just, these notes are for you, you will look at these notes, they will help you remember. The video I'm going to play now will explain, hopefully, in a simple way, what causes charges and how you end up having positive charges, negative charges, and neutral charges.
You may be walking across a soft carpet and reaching for the doorknob when suddenly, zap! To understand static electricity, we first need to know a bit about the nature of matter. All matter is made up of atoms that consist of three types of smaller particles: negatively charged electrons, positively charged protons, and neutral neutrons.
Okay, so EPN, electrons, protons, neutrons, but observe that now when we're talking about electricity, we will mostly be concerned with electrons and protons, because these are the ones that actually have charges. Neutral, the neutron doesn't have any charge, that's why it's called, it is neutral, okay?
Normally, the electrons and protons in an atom balance out, which is why most matter you come across is electrically neutral. But electrons are tiny and almost insignificant in mass, and rubbing or friction can give loosely bound electrons enough energy to leave their atoms and attach to others, migrating between different surfaces. When this happens, the first object is left with more protons than electrons and becomes positively charged, while the one with more electrons accumulates a negative charge. This situation is called a charge imbalance, or net charge separation. But nature tends towards balance. So, when one of these newly charged bodies comes into contact with another material, the mobile electrons will take the first chance they get to go where they're most needed, either jumping off the negatively charged object or jumping onto the positively charged one.
Okay, so guys, I hope that we all know this is what we call static electricity. I'm sure you've all had a situation where you walk to the door and you just want to open the door. And then when you just touch the door handle, then smack, right? You get like that little shock. This is what is being explained here. To say you have both positive charges and negative charges in your body. But because of friction and because of how we rub against different surfaces, some of these electrons may move out of our body, causing an imbalance of charge. And then that imbalance has to be corrected. Those negative electrons which have moved out of your body or moved out of one object have to go back into your body. So when you then touch the door, that's now the opportunity that is there. I'm giving the example of a door handle. But you know that there are several students, you may even touch a colleague, you may even touch one of your classmates. And then when you just touch them, there's a shock, right? Because one of you is having a charge imbalance, okay? So what I will need you guys to do is to play this video, and then when you listen to it once, make sure that you play it again and you listen again so that you can get a grasp, okay? So even now, you may just pause the video, go back maybe 2-3 minutes, listen again to what is being said in terms of the movement of these charges.
In an attempt to restore the neutral charge equilibrium. And this quick movement of electrons, called static discharge, is what we recognize as that sudden spark. This process doesn't happen with just any objects. Otherwise, you'd be getting zapped all the time. Conductors like metals and salt water tend to have loosely bound outer electrons, which can easily flow between molecules. On the other hand, insulators like plastics, rubber, and glass have tightly bound electrons that won't readily jump to other atoms. Static buildup is most likely to occur when one of the materials involved is an insulator. When you walk across a rug, electrons from your body will rub off onto it, while the rug's insulating wool will resist losing its own electrons. Although your body and the rug together are still electrically neutral, there is now a charge polarization between the two. And when you reach to touch the doorknob, zap! The metal doorknob's loosely bound electrons hop to your hand to replace the electrons your body has lost. When it happens in your bedroom, it's a minor nuisance. But in the great outdoors, static electricity can be a terrifying, destructive force of nature.
So just imagine getting hit by lightning. I'm sure nobody wants to get hit by lightning, but it's also something that happens because in the clouds, whenever we see lightning, we just came out of a very heavy rainy season, and there were a lot of lightning flashes, and then thunder then follows. That lightning flash is basically electrons moving from the clouds, moving towards the Earth's surface, okay? Because in the clouds, you're going to have a massive number of negatively charged electrons. They can only be negatively charged anyway. So these electrons will now be attracted towards the ground because the ground is also having a lot of positive charges. So there is an attraction. One thing that we must remember also here is how you have like charges repelling, which means that they go away from each other, but unlike charges, they attract, okay? So what you have is negatively charged electrons who always want to move to where they are positive centers, positively charged particles. Because positive attracts negative, north attracts south. Unlike charges attract, okay? Unlike charges attract. So all that is trying to happen here is the universe or the world or whatever object always wants to be in a state of equilibrium. I hope you know what the word equilibrium means. You can look it up in your dictionary. State of equilibrium where positive charges are equal to negative charges. In the video, you also saw examples of conductors and examples of insulators. Okay? What I did is I put an exercise. There's an exercise here that I need you guys to submit on Friday the 26th. This exercise, you'll find it on your PDF. It's there. Make sure that you answer this exercise and you send it to the same email, to my email, right? You still have the email. I'll put it again on the WhatsApp group so that you guys know where to send this exercise. But before we finish this lesson, I just quickly want to introduce this concept of an electroscope. I'm not going to explain it because I will explain it in detail in the next lesson where I talk about electroscopes, how you charge an electroscope, how you discharge an electroscope. Okay? So, before we just leave, the electroscope is fine. Just take a look at it. So make sure that you understand what the electroscope is. If you don't know it, some of you actually did projects or practicals when you were still in primary on how to use an electroscope. So we also have some examples of static electricity. Static electricity is non-moving off electrical charges, right? Electrical charges held by a material. So when we're saying you touch the door handle and you feel a shock, that's actually static electricity. It's just a temporary movement, a temporary shift of charges from your body to an object or from an object to your body. And these are examples of static electricity. We'll talk about them in the lesson proper in the WhatsApp. Okay, so guys, thank you very much for watching the video. Please watch it once, watch it twice. Make sure you get to understand, read up on the material, and then I'll talk with you guys during the actual lesson. Thank you.